Nice to meet you. So, very soon.
Why not?
Alright, so next up is Corey Quinn. He's going to introduce us to SaltStack. Again, I'm quite interested because I literally have not seen anything about it, so it's interesting. Yeah.
There we go. Oh, perfect. I won't need all of that. They told me 25 minutes, so
Yeah.
try to be under that. We'll pay it forward. Okay, before I dive into this, can I see a show of hands of who's ever run Salt before? Okay, roughly half of the room. That's quite reasonable. The reason I ask is just because whenever I give these talks, it seems that the audience is sort of varied as far as their level of experience, level of exposure. Some people have never even heard of it before and just wanted a seat in the room they could actually get into. Other people have been contributing for it for years and just want to ask fun questions at the end. It's an interesting place. First off, I'd like to apologize a little bit. They wound up cutting times in these presentations, so I know I promised a demo in the write-up, but unfortunately we're not going to be able to deliver that at this point. But we do what we can. Sorry for the false advertising on this. Okay, so who am I? To answer the question initially, I do not work for SaltStack, although Dave in the corner does, who will be fact-checking me on everything I say that's stupid, just most things. I'm a technical consultant at Taos, a company based out of the greater Bay Area in California. I'm also staff for the Freenode IRC network in my spare time, where we contribute to things like FOSDEM. And I was number 15 to contribute to SALT, which is kind of awesome that we're above 500 now. It lets me talk about things I remember way back when. At the moment, I'm currently packaging it for Homebrew for Mac, but I spent an interesting year as the Ubuntu packager as well. And didn't make it onto the slide, but 3 days ago, I wound up passing the newly created SaltStack Certified Engineering Certification. Fantastic. That went on the resume. Oh, yes. Okay, so what is Salt? This is not going to be an in-depth explanation of everything that Salt does, because at this point, the project has grown and blossomed in such a way that this would take several hours to go through, and frankly, no one has that kind of attention span, least of all me. We're going to be relatively high level, an overview of what it does, and I'm going to come back toward the end with a couple of the high-level features that Salt does that you may not have heard of before. So what we're going to do is we're going to start with the basics of what Salt actually is. It's configuration management, meaning remote execution. And as far as what those are, let's break them down one at a time. Configuration management, as I see it, really consists of 5 primitives. And there's no configuration management system out there that I'm aware of that doesn't do these 5 things. As once you wind up achieving all of these, you effectively have control of the node. And that's not particularly difficult these days, and it's not hugely interesting. Everyone does it, but the question is what else is actually out there? Endless studies have shown that anywhere between 4 to 10% of companies out there are running a configuration management system that was not developed in-house. So far and away, the most common thing people are still using in 2014 is SSH in a for loop, or something built around RC. This is somewhat unfortunate, given that people are reinventing an awful lot of wheels, and it doesn't necessarily have to be there. Okay, now that we've covered what your configuration management is, there's really only one primitive for remote execution, which is to do the thing over there. You can think of it like a flamethrower. Basically, I want to set that thing over there on fire. Done. Problem solved. The nice thing about Salt is that it leverages a message bus to do this. So you can do the thing everywhere, or on a very clearly defined subset of things. And it winds up, so you're not winding up doing this in series. You're actually going parallel throughout your entire environment. And at this point, it does scale to tens of thousands of nodes. And this has been tested in a number of environments. LinkedIn, for example, is currently running this at that scale. It's kind of an interesting thing to see. So one of the things that I recommend to just dive into Salt, what makes it a little bit interesting compared to other contenders in this space, is the simplicity of the configuration. It doesn't have anything approaching a DSL, it's pure YAML at this point. In fact, this is not an abbreviated example, this is actually taken out of running a productive environment. It starts off by defining, all this does is handles HTTPD. Unlike a lot of vendors in this space, one thing that's probably worth pointing out is that it does have a dependency model that goes top to bottom, which is nice. It doesn't randomly allocate that. That was actually added in relatively recent generations. So it starts off with obviously defining that the package has to be installed. It does that. It then winds up managing the file itself, obviously the configuration file, and it gives it a source. That source can be a static file on disk. It can also be templated out with Jinja, which we're not going to dive too heavily into. And one thing that I want to point out as well is that it then defines the service as running. And I forgot code there. At that point, it watches the file, so it will restart the service when that file changes. And lastly, what I want to point out that makes this a little bit interesting is the require statement at the end. If it goes top to bottom, then why would I bother to put in a require there? Simply put, because if I don't require it and something goes wrong putting that configuration file into place, it'll just continue iterating through it. If that require fails, it will not start the service, which actually winds up providing a nice failsafe. Picture a scenario of adding a load balancer, adding a web server to a load balancer, where you don't actually have static assets in place on the web server. That's how you tend to have embarrassing production outages. Okay, one other interesting thing as well that takes it a bit beyond this is something called the event reactor system. And this is where Salt really wants to shine. You just saw the dependency model that I laid out. That was not a random thing. Because what this does is effectively does the same thing. If a file changes, restart the service. If this, then that. What the event reactor winds up buying us is it gives us that same type of dependency model, only we're no longer talking about a single node. We're talking about things like if this web server comes up, then add it to the load balancer. If that server load exceeds a certain threshold, remove it from the load balancer. You essentially wind up being able to map dependencies and have cause and effect relationships throughout your entire environment. This is something that traditional systems, particularly our old friend rsync and SSH, tend not to do as well as you would hope. It's environmental orchestration, and that's sort of a new and interesting thing. Something else that's been included in Salt for a while as well is called SaltVert. It's actually a built-in part of Salt. It's not a separate project. And this buys us a few interesting things. Specifically, it lets us deploy virtual machines. Today, KVM is the number one, so basically the only first-class citizen, although support for LXC is coming up, as well as Zen. At SaltConf 3 days ago, we were also given an interesting presentation on how it integrates well with Docker, which was presented here 2 talks ago. It's really turning into an interesting space. What this winds up doing is this adds a great abstraction layer on the business of instantiating and running VMs. Being able to precede the image with its own, with Salt's configuration management system means you can decide to spin up a VM on a particular hypervisor in your environment, and it comes up automatically populated, which is rather nice. But at that point, that's a neat idea, but it also starts speaking to something that's a little bit higher level, and that's called Salt Cloud. What this does is it winds up provisioning into both private and public clouds. Yes, welcome to the cloud. It's where we DevOps. In the next Salt release, this is actually going to be merged in as well as a component of Salt, no longer a separate project. That's already been done in the current release candidate, which we're expecting to release this coming week. And what this serves as is an interface to cloud providers, which is fairly comprehensive at this point. And what this does is not just a list of, ooh, look at all the things that we support, but this represents something that we tend to be driving towards as an industry, whether we realize it or not. For example, as a consultant, I wind up speaking to a number of companies that are doing migrations either into or out of AWS, moving it in because of the rapid provisioning and instantiation of environments, and moving out because holy crap is it expensive to do it at scale. When you can build a data center for what you're spending in Amazon in less than 3 months, it's really time to consider maybe doing something else. The problem is, and the reason I pick on Amazon for this, is that they are obviously the market leader with a lot of very interesting platform-specific services. Take RDS, their database service. That's great, but no one else really offers a database service at that same layer. So what this really speaks to is what it's going to take going forward as we start building out cloud environments that are truly portable, is that we also have to wind up building services as well, rather than relying on the ones that providers can do us. If you, rather than going with RDS potentially, you instead define some form of, you design a state within Salt or whatever you're using. This doesn't need to be Salt specific. And you wind up spinning up your database service inside of a container. If you wind up restricting your interaction with AWS or any other cloud that you're using to basic primitives, stand up an instance, spin down an instance, add it to a load balancing layer, and then have everything else defined in terms of what happens once those instances are up, you've bought yourself tremendous portability. Obviously, it does wind up being sort of a test because you have to figure out how to scale it sooner rather than later, as opposed to once you try to move off and then reinvent the wheel that's already bought you a tremendous amount of technical debt. This is sort of becoming a new best practice in the industry that some of us haven't quite fully realized yet until we wind up smacking us on the face a couple of times. As a consultant, I get to see it a lot, but people who are embedded in various shops either are just starting to realize it and don't have the luxury of moving on to a new project in 6 months so they can forget and do it better next time. So it's definitely worth calling out as one of those dependencies. If you manage to target common APIs, your migrations wind up hurting a lot less. As I mentioned earlier, that we're definitely looking at a point now where there's a transition in going on in the configuration management state, the configuration management space. Node management has been relatively solid for a number of years. It started with CF Engine, then Puppet and Chef wound up addressing that. But now with things that are coming up like Salt and Ansible, we're really starting to talk a little bit more about the ability to manage entire environments. When you start thinking more holistically and being able to interface between different services, that really becomes a powerful thing, and it drives towards a new way of looking at your environment. So the real fun part about this is, so what I've talked a little bit about what's coming, but specific to Salt, what's next? What is it that we're looking to wind up doing? It's a hard question to answer because probably in the time I've been giving this talk, 3 new pull requests have come in, each with a new feature. To say that Salt moves rapidly is being a little bit understating the case. There's currently a project in the works that's going to significantly shore up the integration with Docker. It's already working in an early alpha stage, but it's not there yet. And there's a separate project that I want to go into very slightly that's actually, sorry, before I dive into this, one thing that's interesting about Salt today is that it's built on top of 0MQ, which serves as the transport layer. Very soon, that's going to be replaced with a transport that by default uses UDP, could also be TCP as well. It's currently in development and is just announced this week, called Rate. It's this is sort of new. This hasn't really hit the configuration management space, so you're pretty much seeing it here first. Hooray! Secrets. What this does is it makes the communication protocol very pluggable. You can drop in 0MQ, which is there today. You can use Salt SSH and run the whole thing agentless and just use our old friend SSH. But now you can also drop in this as well, which is sort of forcing a refactor of how things have been addressed before, which means other transport layers are available in the future. What this does is it means that your actual queues wind up, you have multiple queues per socket, which allows for things like packet prioritization, and it scales up rapidly. This very realistically takes Salt from being able to scale from tens of thousands of nodes to hundreds of thousands of nodes, which is turning into something relatively interesting. Not a lot of companies are at that space yet, but it's coming, and it's really neat to be able to see it. At this point, it also winds up kicking encryption down to the socket layer, which is rather convenient, because at that point, encryption becomes pluggable as well. The value of that is that it winds up using published crypto libraries, which means that at this point, Salt can actually get out of handling the crypto space itself, which in the past has led to some interesting challenges, as I'm sure some of you have heard. At this point, this has been my talk, and if you This is something I've been riveted by. It's something I've been talking about for over a couple of years now. And it's something that I really hope that people wind up seeing a bit more of. The next talk, just so you're all aware, is David Ludercourt from Puppet Labs, who's going to talk about a project that's near and dear to my heart, provisioning with Razor. So it's definitely worth sticking around if you're on the fence about it. Are there any questions I can answer for anyone? Yes? To whom? Never heard of it. Sorry, so your guess is as good as mine. Sorry. Yes?
Well, SaltStack goes a bit on the waters of managing the lack of separation there. You know, we have all these new tools that actually make it very easy to separate or between the application there. But SaltStack is kind of making the waters.
You're right, it is. What's interesting is the way that you can actually wind up structuring your state tree. You can lead to a very clear separation. There are a number of shops as well today that are using Salt to orchestrate existing Puppet or Chef environments, to use existing other systems entirely for management of nodes, but then turn into Salt for the ability to essentially orchestrate those environments. At its very basic level, it acts as an incredibly powerful replacement for SSH in a flow. If all you're ever using it for is to kick off runs of your Puppet nodes, just so you don't wind up having everything fire at once and destroy your Puppet master, that alone is sometimes worth looking into. Does that answer your question? Yes. Oh. Anyone else at this point? Perfect. Thank you all very much for your time.
So we have like 15 more minutes. If you have something of like a demo or something.
Not prepared at this point. I'm still 25 minutes in the most.
Okay.
Sorry.
Yeah, no problem. In that case, we'll
the interpreted dance? Wow!
climb on the table and. All right, then I guess we'll have a little break because otherwise we're going to be too much ahead of the schedule. So we'll just take a 15-minute break and then continue with the next topic. Thank you very much.
Thank you.
So are you hanging out here all day? Are any of our other chefs here? I'm gonna go check out the chef. Yeah. Finally. You're leaving now. Okay. See you around. Yeah. One of us should remember that. Hopefully you. Yeah, we have a lot of analysts coming through.
Oh, yeah, there you go.
So, you want me to wait till 25?
Yeah, okay. Oh, we're doing video?
Recording the screen.
Where's your friend? You'll have to bring him so that you're in.
We have like 10-15 minutes off.
Let's see. Okay, yeah. Okay, yeah. Good luck.
So we're going to be filling up the whole room. So over there, all those empty seats in the middle. Just everybody move to the middle. No empty seats.
Actually, yeah, I mentioned you Talk had already started. We'll start when the room is full.
I have my stuff at the Thanks.
Very
Thank you.
We have a bunch more seats over there. There's a free seat over there. So not to confuse everyone, but so the SaltStack talk already finished. I don't know if somebody came here for that, but we're waiting for the Razor talk, which will start at like, I don't know what time it is now. It'll start in like 15 minutes. Yeah, there's one in the middle. If all of you can just move one, if you guys can just move one seat over. Yeah, otherwise somebody's going to have to jump 7 seats to the middle. It'll be easier if you just move one seat over. There's one more seat here. There's some places. I see 2 seats over there on the last row. So we'll do the same exercise as we did this morning, since we have another 13 minutes until we start. I want everybody to speak to a person that's sitting next to you, give them a hand, and ask them why they're here and what they're trying to learn. So you can actually talk. Go ahead. I see one more seat empty. If anybody has an empty seat next to them, you can raise your hand. There's one empty seat over there, right? I'm mistaken. Yeah.
One over.
Mina, are you sitting there? Let's get started then. Alright, so next up we have David Littercourt, as I see in his slide notes here, founder of Obvious, which is an incredible tool, but with an incredibly difficult grammar rule set. Anyway, he'll be talking about Razor, a provisioning tool, and I'll leave to him to explain what it does exactly.
Thanks, Walter. Thanks, everybody, for coming. As I said, I'm David. I write provisioning software. And I've been with Puppet Labs for since May of last year, about 9 months now. But even though I'm pretty new to Puppet Labs, I've been in the Puppet community for much longer. I ran across Puppet pretty early on, in late 2005 or so, and did a bunch of stuff on it, pushed it into Fedora, and I've been around it one way or another for a long time. And one of the things that came out of my exposure to config management through Puppet, because I'm not a sysadmin by background, I'm a developer. One of the things came out of it was Obvious, and if you modify your config files still with set, grep, and awk, stop doing that right now, and check out Obvious. But this talk isn't about Obvious, it's about Razor, about provisioning. Provisioning is one of these words that mean a lot of things to a lot of people, kind of like configuration or systems management. For purposes of this talk, what I mean when I talk about configuration and about provisioning is this sort of situation. You have a lot of machines and you need to get them to do something useful. Hopefully your machines aren't sitting in the backyard. Hopefully somebody's racked them and cabled them up and they're ready to go. But traditionally Puppet has had kind of a first mile problem when it comes to getting going. Because Puppet really only starts after you have enough stuff on your machines that you can run an agent on there. And Razor is a tool to kind of close that first mile gap. It's of course not the only tool to do that. There's a ton of tools out there to help you with Pixie provisioning. There's a ton of open source tools that do it. Each of the big management packages has some provisioning functionality, and there's of course, sure, everybody in here has their favorite Perl script, the 1,000-line script that does everything anybody might ever want to do with Pixie provisioning. But if you look at them, they all, they kind of fall into two piles. One of them, they do too little, and the other one, they do too much. The tools that do too little are the ones that just stop once they've installed all the packages, that end when you have a kickstart file. You have to run through a kickstart file during your install. Because you're not just installing for the hell of it, at some point you need to manage that machine too. And so the other pile, the tools that do too much, they realize that that's a problem and you need to do something to get more fine-grained management than just plonking packages down, and they grow all this config management functionality. But that's of course the wrong place for config management functionality, because your provisioning tools only involved at the very first time you build your machine, but you need config management on an ongoing basis. So Razor tries to be the Goldilocks of provisioning tools. Don't do too little, don't do too much, do just the right amount. And the way it does it is that it makes it very easy to, once a system has been built, to hand it off to a config management system for further maintenance. So the philosophy behind Razor is that you just install the bare minimum of whatever operating system you're installing, and then enroll it with Puppet or Chef or some other config management tool, and then do the actual personalization of the system with that. And since there's so many variations of provisioning tools out there, to get a better idea, I made up a little user survey. Unfortunately, I didn't have time to talk to any users, so I just made up the answers too. And so we've done a lot of software engineering research with that. That's how that happens. But to give a little prehistory about why Razor came about, or how it came about, and why it does what it does. It was started by two guys at EMC, they're now at VMware, Nick Weaver and Tom McSweeney. They launched it in the spring of 2012 at EMC World, and then in the fall of that year at PuppetConf, they announced that they would move maintenance of Razor over to Puppet Labs because it's a really good fit with Puppet, but also because they felt they didn't have the time and resources to really push it forward. And what's happened since then is that over the last 6 months or so, in the early summer, we took a look at where the code base was, the initial code base, and kind of lessons learned from people using it. One of the lessons was that it was really hard to get the initial code base installed and going, and of course to maintain it. And so we decided to rewrite the whole thing. And my talk is about the rewrite. At this point, the initial code base is legacy. If you have an installation for that, great, but nobody should be installing that code base. Use the rewritten code base. So one of the things that makes Razor unique is that it deviates from kind of the general approach of these Pixie provisioning tools that try to make you look at your machines as pets. These things that you know intimately well, and you have a personal relation to them, and you really care about them, right? When somebody comes, hey, build me a web server, database server, whatnot, you go down the data center and look at your 500 most beloved servers and pick the one that is going to do what you need it to do and go back to the office. Enter the MAC address into your provisioning tool, and then hopefully you've got a machine at some point. So Razor kind of taking inspiration from how people use clouds and trying to move that a little bit into the bare metal world, and Pixie provisioning world wants to look at your machines more like cattle, as things that are largely interchangeable. They have different characteristics, but within each group, they're pretty much the same. And just like with cattle, you have dairy cattle and cows that you raise for meat and maybe for breeding or for showing off at some show. But within that group, within each group, all the milk cows are pretty much interchangeable. And the way Razor does that is that when a system when Razor first encounters a system, it puts it into what in Razor lingo is called a microkernel. It's really just a small Linux image that boots on that machine, runs factor, and sends the facts back to the Razor server. And because of that, your Razor server is kind of has an inventory of the hardware that you have. And then later on, Razor decides what should go on there based on policy that you've set up. And so in your policy, you talk about what should happen with machines that have this much RAM and these many cores and whatnot. And based on these policy and rules, Razor then decides, this should get rel, or this is a node that should get ESX installed. As I said, the rewrite, we changed a few things around. One of the things is, we use Postgres now as the database, just because Postgres is awesome. But yeah, I mean, the database with Razor is not a huge concern. We've literally storing tens of kilobytes of data for each node, so you can do the math, how many nodes you would have to have before the database gets a respectable size. We also use Sinatra. The server is written in Ruby, and we use a Ruby web framework called Sinatra. And if you haven't encountered Sinatra, you can think of Sinatra as Rails after a very, very serious diet. It's a really nice framework to write a web service. And the one thing that's probably a little unusual, I mean, so far that's pretty standard web stack. We use TalkBox, which is kind of a plugin to JBoss that turns JBoss into a Ruby app server. I don't know how many of you have deployed Ruby apps, and before you know it, a simple application consists of like 10 daemons, your web workers and some background workers and something that reads email. It's a nightmare to manage, right? Because now you get to babysit 10 different things and monitor them and all that. The nice thing about TalkBox is that it lets me as a developer do all these things, but it does it in one process. So as an admin, you're just watching this one process instead of this myriad of little things. Right, so the one thing that's missing from here, since I've been talking about Pixie provisioning so much, is a little bit of the need for Pixie provisioning. What about DHCP, what about TFTP? And there, Razor also deviates from a lot of the Pixie provisioning tools that kind of naturally branch into managing all that for you. Razor does not do that. We don't really care what you use for DHCP or TFTP, DNS mask, don't use DNS mask. DHCPD, what have you. All we need you to do is put two files onto your TFTP server and set your machines to Pixie boot the usual thing. But once you put those two files on there, one of them is the iPixie firmware, and the other one is a little script for iPixie that basically tells nodes once they come up, go and talk to this other server over here, the Razor server. The genius of iPixie is that it lets you, it gets you out of the TFTP malaise of you can't really do anything, and lets you do all the booting via HTTP. And now we can write the web server that has interesting behavior, does useful things, just to boot machines. And so once you've got those two files set down, you don't ever have to touch them again. Everything happens on the server. Kind of in terms of topology, Razor has really two APIs. One is a public API that you can think of that as the management API. That's what you use to tell the server what the policy and rules and whatnot are. And then there's on the other side there's a kind of private API that nodes use to talk to the server while they're getting installed or while they're booting. And that private API really only comes into play for you if you decide to write your own custom installer to do useful things, because then you need to know how to get files from the server, how to tell the server to log something or the thing is that the public API, we have proper authentication around that. We use basic HTTP authentication, and we use a library called Shiro underneath that makes it really easy to plug it into LDAP or a bunch of other things. So the public API is pretty well secured. The private API, just by its nature, you can't really secure, because there, when a node comes up and says, "Hey, I'm a machine that looks like this," we just have to believe it as node. So on the back end, you have to secure that network by physical means, like making its own VLAN or just completely segregated from the rest of the network. I think for people who do pixie provisioning, that's nothing new. How many of you actually do have to manage physical machines, pixie provisioning? Yeah, when I started doing this, I would have never thought that there's that many hands, because everybody's talking about cloud. But I mean, it's still a real problem to do provisioning. Huh? Yes, that too. Yeah. I'll talk about that at the very end a little bit. Okay, and so the public API is kind of fairly garden variety REST API. The one wrinkle is because it's really icky usually to modify things over REST, and it gets really awkward. To change things, we have commands. So you issue a command to create a policy or modify a policy instead of doing weird gymnastics with representations of REST objects. But the objects you need on your server are kind of the ones that are on here. Policy is the most important thing that ties everything else together. You need a repository or multiple repositories. That's the bits that you eventually want to install on a machine. You can either just point the Razor server at an existing repository like the Yum repo that you have sitting somewhere or apt-get repo, or you can hand it an ISO and import it on the Razor server itself. That's what people usually do for like Windows and ESX installation. They just import an ISO into the server. Broker is kind of Razor's lingo for the thing that does the handoff to the contract management system at the end. So there's a Puppet broker, there's a Puppet enterprise broker. Somebody in the community wrote Chef broker. We don't ship that, but somebody in the community actually wrote a broker that just sends a signal on an AMQP message bus for the internal infrastructure. So you can, with a setup, you can do much more than just hand off to a contract management system. And I mean, broker, at the end of the day, it's a fancy word for a shell script. It's really, really not much more. Tags are named rules, essentially. The way Razor works is that when a node comes in, Razor goes through all the tags it has and the rules that are associated with them and checks whether those rules match that node. Whether your rule might say that it must have more than 8 cores and 16 gigs of RAM, and then you tag it as a medium big machine. And all the same policy also carries tags, and once the tags for policy and the tags on the node match, the policy matches and gets applied to that node. And tasks at the end, those are the actual things that do the installation, the kickstart scripts and all that. We actually for tasks we went through a bunch of naming gymnastics because we initially called them installers, but we want to do these things more than just installation. So eventually we set it on tasks after a few detours. And to write an installer or to write a task is actually, once you have the installation automated, so once you have a kickstart script and maybe a post-install shell script together, getting that onto your Razor server is a matter of writing 5 or 6 lines of metadata about what these lines are. Out of the box, we have installers for these things on the right. So we have an installer for ESXi. That was one of the initial use cases that Nick and Tom had for Razor. They wanted to deploy ESXi, and that's a real joy if we haven't done that. They wanted to deploy that automatically. We also have installers, of course, for the various Linux flavors, RHEL, CentOS, Debian, Ubuntu. And then the thing I'm really excited about, which I didn't think we would get not that quickly, is we also have a Windows 8 installer now, which is, I don't know how many of you install Windows on a regular basis. It's fun. But we have, and by all accounts, I haven't tried it, but by all accounts, it actually works. And so you can use Razor to provision pretty much all the other systems you usually encounter. The installer itself is kind of a linear process. You can say, the first time we boot with this installer, you do this, and that's usually you download some kernel init.rd that is actually the installer, and then the second time we boot, we do something else, and the third time, so on, until eventually you're done installing and the thing is just set to boot locally. From then on, you have the machine in production, and it just boots locally. You could, for example, write your own installer that as the very first step does some configuration of a RAID card, right? Boot into some special image that lets you modify RAID config with whatever tools you use. And then after that, boot into the real operating system itself. Pretty easy thing to change. Okay, so everything is about nodes in Razor, right? Those are the machines that we really do all this for, and why we do that, because we need to put something on these machines. And from Razor's point of view, the node largely consists of those four things. We have a little bit of information about the hardware that iPixie sends us, MAC addresses, serial, I think. You don't get very much information out of iPixie just because these firmwares are pretty restricted in what they can tell you. We have facts, which is right now a standard run of factor, which includes block devices and how much memory and cores and stuff like that. Then a fairly recent and really interesting addition is metadata. You can associate just a bunch of key value pairs with a node. And what makes this really interesting is you can do that both through the API, so you can make a call and set some metadata key, but you can also do that from the installer, like the installer can call back, or you can of course read those in the installer and make decisions based on certain metadata tags. So if you're totally crazy, you could push your whatever partitioning you want to have on your machine into metadata on your node, and then the installer can pull it out and lay down your custom partitioning scheme. And then the last thing is state, which tells you whether the machine is installed. And that's right now the only thing, but we'll add more flags there about what the node is doing. And those four things are all accessible when you write rules. So the decisions about what gets provisioned you can base them off all these pieces of data, which gives you a good amount of flexibility. Another recent addition that's not on the slide is that we also added IPMI support. So now you can use Razor to both enforce power state, say this thing should be off and keep it off and check that it's off every so often. You can reboot it and you can turn machines on or off, on and off. Right now it's kind of simple. Basically, we support as much IPMI as IPMI tool does, but we want to add support for other remote power management. And so just a few examples of what Razor can do for you. Of course, you can build machines with it and add to Puppet or some other config management systems like Chef. Your initial use case of building nodes and setting them up with vCenter, you can that's actually Puppet modules that help you do that. But Razor's well integrated with that. One of the things I find really cool is you can use it to provision OpenStack, because at the end of the day, you'll just you use Razor to lay down a basic operating system, get the Puppet agent going on that machine, and then you use the OpenStack Puppet modules to actually turn your machine into a Nova compute node or Swift storage or what have you. And then something that we're taking kind of baby steps towards, but I think that's what where Razor will go in the longer term is something that manages the life cycle of your machines. One of the really important differences between kind of Puppet's notion of what a node is and Razor's notion of what a node is that Puppet thinks of a node as something that lives as long as the operating system is on there. If you take a machine and reinstall it, Puppet will think, oh, that's a brand new node that I've never seen before. Whereas Razor really follows the machine, the hardware itself. It's not confused by reinstalling things. It does that. And so you can use Razor to build complex life cycles. Like one of the things that people seem to do quite a bit is when you decommission a box, do a secure wipe before you install something else on there. And that you can actually trigger just by setting metadata flags and writing rules in a somewhat clever way. Something where we need to do more to make it really smooth is updating BIOS. If you, once you know that the BIOS on these machines need to be updated, it would be really cool if you could tell Razer do that, and then on the next scheduled reboot, you update the BIOS. So you don't need to have a specific reboot schedule just to do the BIOS update. You might have a reboot machines every 2 weeks policy. So when it reboots, Razer would then make sure that it first boots the BIOS updater image, and then once that's done, it goes back to booting locally and running whatever is on the machine. Okay. I've got a few pointers here. I have a couple minutes for questions. If you have questions. If you have questions after the talk, like tomorrow or so, we have a mailing list, IRC channel, and so on. Don't hesitate to get in touch there. No, I mean, the thing that's kind of awkward is the flipping back and forth between I'm doing a BIOS update and so the thing is that Razer right now, once you've run an installer against it, considers the node installed. That keeps it from going through the policy table again. And so we need a way to mark some of these tasks as non-destructive. Right? Actually installers are destructive, right? You would never want to apply them to a node that is already installed. But some of those things are non-destructive, like a BIOS update, and you would want to distinguish between those two and allow applying the non-destructive stuff even to nodes that are installed. TPM brings back flashbacks to a previous life. I don't know. I want to go there, and I don't know how much people would actually want to use TPMs for that, or how much they're actually using it for anything. So Intel would love that idea. Yeah, not explicit. So the initial implementation had a state machine, and then when we actually looked at the installers, which in the initial thing were called models that people actually wrote, they were all linear processes. There was no real use of the state machinery. It just made things very complicated. And so one of the decisions we took with the rewrite was installs are just linear steps. You do step 1, you do step 2, you do step 3, but there's no branching and cycling and all that. But some of that we'll get back with the additional data we have about a node, and things like what I just said, that we to distinguish between an installed node and or between destructive tasks and non-destructive tasks, and allow non-destructive tasks against installed nodes. So behind that is probably implicitly a notion of life cycle of the machine, but it's not really exposed, because I think that's just too hard for people to really make use of. Yes? We don't have, so can it revoke certificates and pull stuff out of the Puppet Master? Out of the box, we don't have anything for that, but it's a matter of writing a shell script that actually does that and sticking that into an installer. So it would be a pretty easy exercise to do. Yes? I've heard about Ubuntu's Metal as a Service. I haven't really looked at how they do things. My understanding is that they push much more into a cloud-like mode of operation. I think Razer tries to be very careful to strike a balance between being fairly hardware-centric and fairly close to the way people are used to doing physical management, and the kind of cloud-like features. Because I think there's a gamut of these uses. I don't think you'll make everybody happy by giving them a Metal as a Service cloud tool. So because of that, I would expect that there's quite a few philosophical differences between Bundles, Maze, and Razor. Yes, Steve. Is it better to do? Is it better to do that? So generally, I would say whatever you can do with Puppet, do with Puppet, because Puppet is the thing that worries about the ongoing maintenance and configuration changes of your boxes, and only do the things you absolutely have to do outside of Puppet in Razor. If it's something you need to do to even get the operating system on there, you do it with Razor, and everything else you do with Puppet. Yeah. And I mean, some platforms allow you to do that. On the running system, and others you actually put in the static image. But I mean, if you can do it, Puppet. I haven't thought about that. Yeah, so for starters, I hate the word microkernel because it's a misnomer. It's a small Linux image. That was another thing we changed from the initial cut, is that we moved it to Fedora. Right now we're using Fedora 19. The rationale behind that move is that we as Puppet Labs can't be in the business of hardware support. I mean, there's companies that do that, and they're way bigger than Puppet Labs. So the idea here is that eventually we'll move to like an enterprise Linux microkernel, so that if you have a support agreement with one of the enterprise Linux vendors, you go and talk to them if your microkernel starts because it doesn't like the network kernel. But yeah, right now it's Fedora 19. Yeah, I mean, I actually just noticed that OpenOffice very helpfully made these links pretty much illegible. The first one to the server repo is to Puppet Labs /razor-server, and that's where all the documentation lives to on the wiki for that Git repo. I try to keep everything there, and then the other repos are kind of offshoots, but all the documentation and most of the information is on that. Any more questions? Okay, thank you. Thanks very much.